Okay, guys, let's do checkpoint 6. Okay, so the concentration of OH minus ions in a certain household ammonia cleaning solution is 0.0025 molar. Okay, calculate the concentration of H plus ion and its pH value. Okay, all right, so it would be good for you to determine the strength of the substance itself. So we have ammonia, right? So is ammonia an acid or base, guys? Is ammonia an acid or a base?
Base.
Base?
Base.
Base? We have acid?
Base.
Anybody answered acid? Okay. All right. So I hope nobody answered. Okay. All right. So I hope nobody answered acid. Okay. So ammonia is a base. All right. Second question: is ammonia a strong base or a weak base?
Strong base.
Weak base.
Weak base.
Are you sure it's a strong base?
Base.
Huh? Whoever answered ammonia is a strong base just now, are you sure based on what your answer just now is a strong base? Okay, can you justify why is ammonia a strong base? Okay, that is why I asked you to memorize. Okay, so by right, strong base will be easier because the strong base come from group 1 and group 2. Is ammonia come from group 1 and group 2? And first thing, you have to know what is ammonia. So what is the chemical formula of ammonia? So this is ammonia. So do we have any element, any species coming from group 1 and group 2? Calcium, sodium and whatnot, do we have in it? No, we don't. So other than those two groups, element coming from those two groups, the rest are all weak base. And normally weak base would consist of nitrogen, the electron-rich species. Okay, yes, we do have nitrogen in ammonia. So there's two reasons. We don't have any element coming from group 1 and group 2, and then we have nitrogen. Okay, we have nitrogen, the electron-rich species. So it will be a weak base. There's two reasons why this is a weak base. Okay, so please guys, okay, so we are not yet reaching to, we are not yet having to calculate the pH of weak base, strong base. Okay, belum lagi, we haven't reached that slide, atau we haven't reached that part, but make it a habit for you to determine whether this is strong base or strong acid, or strong acid or strong base, or weak acid or weak base. Okay, make it a habit, because later on it's all about that. You have to identify that first. If not, okay, that part you dah salah, everything will be wrong. Okay, for the following steps. So please be careful. Okay, alright. So it's good to know at least ada different in answer, so that I would comment and I would tegur. Okay, there and then, so that you are more aware on this issue. Okay, so this is common mistake that student made at the beginning of the topic, because they tend to confuse weak base dengan strong base. Okay, alright, so please be careful. Alright, so this is weak base. Okay, alright, so since this is weak base, that means you have to bear in mind when it dissociate, it will produce OH minus. Okay, it will produce OH minus. Okay, and then the concentration, it's just that the concentration is already given. So this is the concentration of OH minus. Okay, all right. So the question wants the concentration of H plus or H3O plus. Okay, let's make it standard. Okay, it should be H3O plus. Like I said, H plus will not be able to stand alone as H plus because it is unstable. It tends to react with water, okay, to produce a stable form of ion, which is H3O plus. Okay, all right. If we have water in the solution so it will combine with H2O to produce H3O plus. So the question is asking for H2O plus and the pH. Okay, all right. So we are going to be using this KW. The easiest will be this one. Okay, we have this value already, and also this one is already given to us. Okay, therefore we can calculate for the H3O plus, and then we are done. Okay, we got this value. So the H3O plus is equal to, okay, and then we want to calculate the pH. So based on the formula, the pH is equal to negative log of H3O plus. Just now we have calculated this one, right? So insert into this, we got the value. Okay, all right. Moving on. Okay, this is how you should be calculating just now, like I've shown to you. Yep. Okay, another question. Question 2. Okay, the pH of rainwater collected in a region. Okay, I give you like 3 minutes for you to solve for this one. Okay. Okay, so try on your own first. We will discuss it after this. Okay, try dulu. Okay, so are you done, guys?
Yes, madam.
Yes, madam.
Yeah, madam.
All right, okay.
Yes, madam.
Right, okay, thank you for the response. Okay, let's go through the question. The pH of rainwater collected in a certain region of the northeastern US on a particular day was 4.82. So this is acidic. Okay, the pH is acidic. So calculate the H plus ion concentration of the rainwater. So we want to calculate the concentration of H3O plus ion of the rainwater. So what is given to us is the pH. So we have this given to us. Okay, all right. So the question wants the concentration of H plus. Okay, do we need to use Kw is equal to H3O plus and concentrate times concentration of OH minus, guys? No, we don't. Okay, even though we have this one, we want to find this one, but we don't have this the information on the OH minus. So this is not suitable. Okay, we can just simply use the formula of pH itself. So pH is equal to negative log concentration of H3O plus, right? All right, so we have this already, negative log H3O plus. So what you need to do is to anti-log this value in order to get the H3O plus. This is by using calculator. Okay, all right, so you get the answer the same as this one. Okay, done with that. Okay, all right, so now let's move on to pH of strong acids and bases. We are going to calculate, okay, the pH value related to strong acid and bases, and then next we are going to calculate the pH for weak acid and weak base. Okay, all right, so this is very important step. You have to know what is the difference in terms of calculation for strong acid, for strong and weak acid for and base. Okay, all right, so let's start from strong acid and bases, and then we will continue with the weak. The concentration of hydronium or hydroxide in a solution of strong acid or base is related to the stoichiometry of the acid or base. It is related to the stoichiometry of the acid or base. Okay, this is so because the strong acid or bases, okay, they dissociate fully in water. That means the coefficient of the H2O plus or the anion or the cation, okay, will be interpreted or will be considered in order to calculate the concentration of these two. Okay, all right. Let's have an example. So we start off with HCl. So HCl is strong acid, right? So HCl dissociate, okay, in water, okay. So make sure that you use the single arrow to produce Cl minus and H2O plus. So since we are dealing with acid, that means you should be producing H2O plus. Okay, guys? Okay, so what it meant here, if initially we have 1 molar, okay, if initially this sebenarnya macam ni, this is the simplified version. This is the simplified version, okay guys? HCl in water, arrow, okay, one direction, producing H3O plus and Cl minus. Okay, if you were to write to represent the dissociation, the process of dissociation, so initially, okay, since this is the initial concentration of the acid, so initially, let's just assume it is 1 molar. Initial, okay, at the beginning of the reaction, that means we don't have this, the product are yet to form. Belum form lagi. Initial concentration of HCl, we only have HCl lah. Okay, we don't have the product. Okay, after a while, the dissociation has proceeded. Okay, so we have the final. After the dissociation, what happened is that we know that the acid will fully dissociate, right? It will fully dissociated in water. That means this 1 molar will be fully dissociated. I mean, it will be totally dissociated. So this one will become 0. Okay, it will become 0 or almost equal to 0. That means there is very, very small amount of HCl left in the reaction, or we can just simply assume that there's no more of HCl left. Okay, so H3O plus on the other hand, since it dissociates fully in water, this one will be 1 molar. Same goes to this one. Again, because this is strong acid, it is fully dissociated in water. It is completely dissociated in water. So that's why initially it is 1 molar. After dissociation, this will be gone. It will be equal to 0, and these two products will be 1 molar and 1 molar. And this is also subjected to coefficient. Since these both ions, the coefficient is 1 to 1. Okay, that means they're 1 times 1 molar. This is also 1 times 1 molar. Okay, so that is what it meant. Maksudnya strong acid is fully dissociate when you have this initial concentration. It also represent the concentration of H2O plus and the anion once the dissociation completed. Okay, all right. So let's KIV this one first, H2SO4, because yes, it is true H2SO4 is a strong acid. But as you can see, H2SO4 is also a diprotic acid. Diprotic means it will undergo 2 steps of dissociation. The first step to produce the first H2O plus, and then another step to produce another H2O plus. But the one yang strong dissociation, that means that fully dissociated, will be the first one. Okay, so this is H2SO4. If I were to show you the steps. Okay, all right. This is the strong version of the fully dissociated. Okay, fully dissociation of the acid. So it will produce HSO4 minus H3O plus, right? And this one, this is the first step. The second step, HSO4 minus plus H2O. And this is not strong anymore. Okay, it will produce SO4 2 minus plus H2O plus. Okay, so the first step is strong. Yang second process is no longer strong acid. This is considered as weak acid. Okay, so that's why that's why I want to KIV this part. Okay, kita keep in view. Later I will come back to this and explain. Okay, whether this is applicable or not to be considered as strong acid. Dia strong acid, tapi this 2 molar is the problem. 2 molar is the problem here. Okay, because as you can see, dia ada 2 step. Since the second step is the weaker step, that means it will not produce. It will not totally produce the H2O plus. So we cannot just simply assume that it will be 2 molar. Okay, unless it is very, very small amount, and we can assume that, there's other consideration that we have to consider lah. So let's just keep this one as KIV. Okay, all right. So kita this one we have discussed just now, settle this one kita KIV. All right. So this is strong base. Both of them, both sodium hydroxide and barium hydroxide are strong base. Okay, all right, so similar to HCl just now, dissociated, so initially it is 1 molar. Again, this is the simplified version. So when this is fully dissociated at the end, after the dissociation, this one will be 0, guys. After the dissociation, sodium hydroxide will be 0. That means there's no longer sodium hydroxide available in the reaction, in the solution. But what we have is OH minus and also sodium plus. Okay, 1 molar and 1 molar. Again, this is subject to the coefficient because they both have 1 to 1 ratio ataupun 1 mole and 1 mole. Okay, how about BaOH2? This is like to compare lah. This one dia ada dua hydrogen kan. This one dia ada 2 hydrogen. But this is slightly different than this one because BaOH memang what we call as strong base. Dia memang strong base. That means 1 barium 2 plus, okay, will carry ataupun will have 2 OH minus ion attached to it. When it dissociate, it will produce 2 OH at the same time. Okay, it will fully dissociate to produce 2 OH minus at the same time. So this is what happened during dissociation. So as you can see, we have 2 OH minus and 1 mole of Ba2 plus. So what will happen to the concentration? Okay, again, Okay, let's assume. So this is initial. We have 1 molar. So after dissociation, so initially these two are 0. So after dissociation, this one will be 0 because they're fully dissociated. This one will be 2 because kita ada di sini coefficient dia 2 times 1 molar which equal to 2 molar. How about this one? Okay, 1 times 1 because the coefficient is 1. Okay, and the molarity is 1 molar. So it is 1 molar. Okay, but what you need to calculate pH later on is this one. You need to be using these 2 molar to be inserted into, first you have to calculate for pOH first lah. Okay, you have to calculate for pOH and then you calculate for pH. Okay, because we are dealing with OH dulu. Okay, alright. So that is why if we have strong acid, we don't need to have the information on the H3O plus or Cl minus because it is understood though. They automatically understood that when we have the initial concentration, oh, this is strong acid, this is strong base. That means it will fully dissociated. Means, okay, that means the concentration of H2O plus or the concentration of OH minus, okay, will be the same as the initial concentration of the acid or base. Nampak tak? Dia understood. Dia automatically, okay, tahu that the concentration will be the same as the initial concentration. And this is provided, dia mesti tally with the coefficient lah. Okay, normally it will be 1 to 1 lah ratio, except for the base just now here. Right, so let's look at the example. Calculate the concentration of hydronium ion and hydroxide ion and the pH of the solution at 25 degrees Celsius. Okay, all right, so let's calculate for A. So how many questions that we have in the question? Okay, you have to calculate the concentration of H3O plus and OH minus and pH. Okay, so there are 3 things that you have to calculate. Okay, so you have to calculate for A and B. Okay, determine whether each of the given substances whether they are strong acid or strong base or weak acid or weak base. Okay, so this is pretty obvious sebab kita baru selesai for strong acid and bases just now kan. So of course lah the upcoming example will be based on strong acid and strong base. Tapi imagine, okay, if you were asked in tutorial ke, in exam ke, okay, you have to identify the type, the category of the acid or base first, whether they strong ataupun weak. That is very, very important. Okay, all right, so HNO3 is a strong acid, CaOH2 is a strong base. Okay, all right, so we have this concentration. That means imagine. So let's just start from the beginning. So HNO3, if you were to write the equation, how would you write it? Okay, in H2Os. Okay, so we have this one direction arrow. It will produce, since this is an acid, H3O plus, okay, and producing the NO3 minus. Okay, because this is a proton donor, guys, so it will donate the H2O and becoming H3O plus. H2O, which initially has 0 charge, when it accepts proton, okay, it now become more positive. That is why you have positive charge. Okay, and O3 on the other hand, initially it has hydrogen, so the charge is 0. Now when it lost the proton, okay, that means it become more negative. But they lost the proton, it become more negative, so that's why the charge become NO3 negative 1. Okay, all right, so initially we have 0.15. Again, like I said, since this is a strong acid, okay, initially the product has yet to be formed. After the dissociation, this one will equal to 0. Okay, this one will produce 0.15 of H2O plus and also 0.15 of NO3 minus. But what we want is this. This one will be used to calculate pH. Okay, all right. So we have calculated H3O plus, guys. So the H3O plus is equal to 0.15 because it is a strong acid. Now, how do we calculate the OH minus? Okay, we may use this one. Kw is equal to OH minus times H3O plus. There's few ways for you to calculate the pH later on. Okay, you may go for POH and then you calculate for pH. Either way, both also correct. Okay, all right. So we have this one. OH minus, we don't have the value yet. H3O plus, we have it already, 0.15. Okay, all right. This is molar, okay? That's why you end up with concentration of OH minus with molarity as a unit. Okay, all right. So you get the value because we have this one and this one. Next, we want to calculate the pH. So this one is the concentration of OH minus. Right? This one is the concentration of OH minus. So if you want to calculate for pH, the easiest would be negative log of H3O plus. Negative log, we have this one already, 0.15. So what would be, or alternatively, if you want to calculate for OH, okay, so, but we have this already. Okay, you can also calculate for POH. Okay, POH is equal to this value, negative log OH minus, which can be obtained from this one. And then you use pH plus POH is equal to 14. Right? So you have the POH and you have the 14. 14 minus the POH, you get the pH. So either way, okay, both methods also are also correct. Okay, all right. That is for HNO2. For CaOH2, you have to bear in mind. Okay, so that's why equation is very, very important, guys. Okay, so this is strong base kan. It will produce Ca2 plus 2OH minus. Make sure that it is balanced. Okay, so initially we have 0.010. So this is yet to be formed. Okay, this is initial, this is after. Okay, this one will be equal to 0. This one is equal to 0.010 molar. This one, don't forget to times with the coefficient. 2 times 0.010 molar. You get 0.020 molar. So this one that you will be using, you'll be inserted into this one, Kw, to find the H3O plus, and later on to find the pH. Okay, all right. Okay, any question related to strong acid and strong base before we proceed to weak acid and weak base, guys? How are you guys doing so far? Are you guys doing okay?
Madam.
Okay, clear?
Yeah.
Maybe we can have like a 3 minutes break, guys. Okay, we can have like 3-minute breaks, and then we will come back to pH of weak acid and bases. Okay, right. So let's have a break first, and then we will continue after this.
7 minit madam.
Back, yes, 3:08. Now it's 3:08 minutes. So let's have 3 minutes break. So we will resume at 3:11. Okay? Empat lah, pergi toilet lagi. Pergi toilet first. Okay, right, so let's continue. Okay. All right. Okay. pH of weak acid and bases. Okay. All right. So the concentration of hydronium or hydroxide in a solution of weak acid or base is based on this. Okay. Let's look at the example. Okay. So CH3COOH is also known as acetic acid. Okay. And then it is not in the list of the strong acid. So altogether we have 5 strong acids. So this is not in the list. So automatically it will be weak acid. Okay. When you know that this is weak acid, that means you have to bear in mind that it will not dissociate fully in water. Okay. And the arrow that you should be using will be the reversible arrow, guys. Okay. It will be the reversible arrow. Okay. All right. So acid will dissociate. Okay. Since this is an acid, you should be producing H3O plus. Okay, and then since it donates the proton to H2O, that means this CH3COH lost its proton. So initially the charge is 0. So since it lost its proton, it will become more negative. That is why it becomes -1 charge. Okay, all right. So initially, okay, imagine before the dissociation, we only have the acid. And this one is yet to be formed, 0, 0. Okay, and then after dissociation, this is still available because it is only dissociated. It is dissociated partially. Okay, so this is still available, maybe less than 1 molar, but still available. And this is also, these two are also forming, okay, which is less than 1 molar. Less than 1 molar. They form, but it is both of them form less than 1 molar of concentration. Okay, so same goes to NH3. NH3 is also weak, is a weak base. Okay, it dissociates in water to produce OH minus because it is a base. Bila dia base, it should produce OH minus. And then we know that base is a proton donor, proton acceptor. That means it will accept the proton from H2O and leaving this H2O as OH minus. When it accept proton, initially dia punya charge is neutral, 0 kan. When it accept proton, it become more positive. So that's why NH4 plus. Okay, all right. So in terms of concentration, similar like what we have for CH3COH just now, initially it is 1 molar. And these two are yet to be formed. After the dissociation, this one, okay, this is after dissociation, this would be less than 1 molar. Okay, because it undergoes dissociation, so supposedly it should not be 1 molar anymore. Okay, it should be less than 1 molar. This one, okay, also started to form, and then the value is also less than 1 molar. Okay, all right. So this is a reversible reaction. So you know this applies the concept of equilibrium. Okay, all right. So if we have equilibrium concept for acid and bases, that means we cannot run away from ice table. Okay, we may need to use ice table in order to solve for the concentration of H2O plus. Because later what we want will be the pH, guys. What we want is this one. We want to know the concentration of this H2O plus and also OH minus. Because we want to insert into the pH. Okay, since this is not fully dissociated, that means we have to predict. Okay, we have to use the ice table. Remember the X. Okay, and then we have to find the value of X. Those kind of things we will be applying into for this weak acid and weak bases. So one good thing you have learned it in topic 2. Okay, this is not something that is totally new to you. This is already, you are already familiar with this concept. Okay, what you need to do is just to apply what you have learned so far in topic 2 in this subtopic. Okay, so we can determine the concentration because at the end of the day, the X will also equal to H3O plus. Okay, so the change, you remember the ICE last time? So this is the negative X, this is positive X, this is positive X, 1 molar minus X, this is X, this is X, this is assumed this is 0, okay? This is just prediction. We predict that the value will be less than 1 molar. Way lesser than 1 molar, okay? Much lesser than 1 molar. So what we want is to find X actually. X is equal to concentration of H3O plus. Okay, so we may use ice table because normally it would involve the quadratic equation, or alternative to ice table, we have this alternative method, which we will be using the simplified equation. Okay, but to give you a heads up, alternative method actually come from ice table. Okay, ice table is the fundamental, is the basic of it. And then from ice table, we would derive a formula from the ice table though. Kita derive a formula and then we have a formula where we can simply insert the value into it and we can find out the concentration H3O plus. But it is derived from the ice table. Okay, so we will look at into that later. Tapi nak bagi you intro lah. Okay, right. Okay, let's try out this example, guys. Okay, nicotinic acid. So it's mentioned here, it is an acid. It's a form of vitamin B3, which is an essential human nutrient. Calculate the pH of 0.1 molar nicotinic acid solution given Ka is this. So Ka is given to us. Okay, luckily the Ka is directly given to us. If, okay, don't be surprised that instead of Ka, they bagi you Kb. Okay, so please know what you want. You must know what that you will be needing in order to calculate for acid. If you are dealing with acid, that means you need the value of Ka. You don't need the Kb, but if the Kb is given to you instead of Ka, you need to change the Kb into Ka by using this one, Ka times Kb, 10 negative 14. Okay, not to worry, you can convert the Kb into Ka. But please bear in mind, if you are given the acid, you want the Ka, you don't want the Kb. If you are given the Kb, you have to change into Ka. Okay guys, don't simply just use whatever is given to you. You need to know what is needed and what is not needed. Okay, alright, so for this one, okay, let's try out the ice table first. Okay, alright, so what is given to us is, the question is asking for pH and the concentration. This is the initial concentration of the acid. And this is the Ka of the acid. So Alan nak tanya pH. We know that pH is equal to negative log F of H3O plus. Okay, and this is weak acid, guys. Weak acid. That means you can imagine that you have to calculate for X and whatnot. Okay, alright, so let's start. So this is the step-by-step process. Okay, you need to have this equation. Make sure that your equation is correct. Okay, so since we are dealing with acid, so you should be producing H3O plus. Okay, so since this acid is also a proton donor, kan? It will donate the proton to H2O and becoming H2O plus. So this one later will have a lack of proton. That means it will be more negative. Okay, alright, so you place in the values. Okay, this is the ice, so 0.1, so initially it is 0. Okay, after a certain period of time, during the dissociation, this is the amount that has dissociated, and this is the amount of concentration, the amount of product formed. And then this is at equilibrium. So what we want is this one, this X, because it represents the H3O plus. Okay, alright, so how do we find this X? You need to have the Ka. Remember, you need to have the Ka because Ka is given to us. So this is the expression. So you have to write the Ka expression first. Okay, and then this is if you replace the equilibrium concentration into this expression. So this is what you have. Kan sama kan step dia kan? Tak ada yang totally new ke apa. It's actually the same. Okay, alright. And then here is the part that we are going to neglect ataupun ignore the value. Remember in topic 2 last time? Okay, we have one slide discussing about the simplifying assumption where we neglect the value of x here. This one, the x kuasa 2 divided by 0.1. This should be round bracket 0.1 minus x. So this one can be ignored. Okay, but we have method. Last time we have method to make sure that whether the x can be ignored or not. Okay, all right. But normally when we are dealing with weak acid, normally the x will be very small, kan? Okay, so it's actually a hassle to calculate this very small value. Okay, we have to go through all the cubic, all the quadratic equation just to find out that the value is very small. 10 kuasa negative 5, 0.000004. This is like equal to 0, right? Okay, so we have to go through all the process, all the mathematical parts just to know that the value is equal to this very small value. Okay, normally for acid and bases, the x will be, the change will be very small, and normally we can ignore the value, normally. But for topic 2, we cannot simply ignore. Okay, kita kena check whether it can be ignored or not. But for topic 3, normally it can be ignored. Okay. So we can ignore 0.10 minus x is equal to 0.10. We can ignore this one, ignore as in we can assume that the x is very small and it is equal to 0. Okay, so that's a value sebenarnya. It's just that kita ignore to simplify the calculation. Alright, so it will become like this, x2 over 0.10. This is only if it involve operation minus macam tu. Let's say we have maybe 0.05 plus 2x. This one, all of this can be ignored. And then later somehow we have like one apa nama tu minus 3x ke. This also can be ignored. But this one yang darab, the multiplication one, you don't ignore that one, okay? And then if you ignore, you nak calculate apa? What are you going to calculate then? Okay, if you ignore all the x. The ignore version is the when it involves the operation tolak atau tambah. That one you can ignore. But this one you cannot ignore because you want to find the x, remember? Okay? Okay, right. So you have this already. So x is equal to H3O plus. Make sure to have this. Okay. Students tend to determine the x and then dia tak conclude that x, the value of x is equal to concentration of H3O plus. Okay. So you have to have this one and then equal to this concentration, the value. And then you can simply calculate for the pH. Ta-da! Yeah. Okay. All right. So this is by using ICE method. Okay, what if we are using the alternative methods? Okay, so what is the apa nama tu explanation behind it? Why do we have alternative method to the ICE method just now? So like I said, alternative method is also known as simplifying method. Kita nak simplify the calculation. Okay. And again, I've mentioned this simplifying method, it's actually come from the ICE table, the ICE method lah. Okay, all right. Again, kita consider the weak acid dissociation. So this is in general the acid dissociation. So this is the ICE table. Okay, let's just assume the initial concentration as C. Okay, so initially we have 0 for the product. And then after a while, it undergoes changes. Okay, so it will be negative x, positive x, positive x. And then at the equilibrium, the initial plus the equilibrium. So the change the initial plus the change. Okay, so since the change is negative x, so C tolak x. And then x for both product. Okay, all right, so we have the KA. So this is how the KA looks like, right? And then we insert the equilibrium part into the KA expression. So this is how it looks like. Okay, and then this is the simplified version. All right, so what we want is the x, right? This is H2O plus, this is the x. What we want is the x. So this is how it is written. Okay, remember this is initially this is C tolak X. After we ignore due to small extent of weak acid ionization, very small changes. Okay, so we ignore this one, C tolak X is equal to C, and then we will end up with this one. Okay, alright. So since what we want is X, so kita jadikan X as our focus, as our headline. Okay, alright. So square root of C times KA, and X is also equal to H3O plus is equal to C times KA. Alright. So that means if you are asked to find the H3O plus, you are asked to find the pH later on. For weak acid, I'm talking about weak acid. For weak acid, you can have the balance equation, and then you can simply use this formula. You can simply use this formula. Okay, but for me, okay, since we start off with I stable kan last time, so I prefer to have the ice, and then I can next I will be using this formula. Okay, because it is a comfort for me to have this ice table, because from the ice table I will be able to see what is actually happening in the reaction. So we have the equation, okay, we have the initial, the changes, and then the equilibrium. So this is by default, and you can straight away write the C tolak X, and then you have the you can straight away use the formula. Okay, students tend to skip this part and then right away use this formula. So what is missing there is you tend to miss out the equation. Okay, so you miss out the equation and you don't know how to write the equation of the acid. Okay, because you dah use terus masuk formula, so you tak ada this equation. So when the question asks, commonly asked question, okay, you have to write the dissociation of the acid, dissociation of the base, okay, and students tend to not be able to write the correct balance equation of dissociation of the acid. That's the problem. Bila you terus pakai formula. If you are using ice table, it's already embedded in the ice table. See? That's the good thing. Tapi dia banyak step kan? Dia banyak step dekat situ involved. So that is why for me, I would have this one, and then I would straight away use, I would have this, the equation and the ice, and then I would have this one. Okay? Terus masuk dalam this equation. Sebab nak practice, nak make sure that I also practice in terms of the equation punya dissociation. Okay, same goes to base. Okay, we are using simplifying method. So this is for base, but please bear in mind that you are calculating for OH minus, because you have base kan, so it will produce OH minus. So this one, the X is for the OH minus, and you need the KB, okay guys, not the KA, you need the KB. So that means if you are calculating for OH minus, you have to calculate for POH first, and then only you can calculate for pH. Okay, so they are the extra step here. Okay. All right. Okay, maybe you can try out this checkpoint 7, guys. Okay, please try out this checkpoint 7. Okay, before that, do you have any question related to weak acid just now? Okay, good, everyone?
Okay, madam.
Madam.
Yeah, so far so good, okay? All right. Okay, so please try out this checkpoint 7. I give you like 3 minutes for you to complete this one, and then we will discuss the answer later, okay? Okay, right. So done, eh? Right. So let's proceed with the answer. Calculate the pH of the solution obtained by dissolving a 0.325 gram tablet of aspirin. And this is a chemical formula of aspirin, and it is an acid, acetyl salicylic acid. So this is weak acid, guys. So this tablet is dissolved in 0.5 liter of water. The acid is monoprotic and the Ka is given. Okay, and the molar mass is also given. All right, so what the question wants is the pH, right? The pH. pH is equal to negative log of concentration of H3O+. So the mission is to find this H3O+. Okay, if you are using the alternative method, you're going to be using this one. H3O+ is equal to Ka times C. C is the initial concentration. So as you can see, it's not given to us directly, but we can find out the concentration. From the mass given, we can convert into mole, and then we can convert into concentration in terms of molarity. We can divide the mole that we have calculated just now, okay, with this volume of water. Make sure that you convert into liter, okay? Right, so you can calculate for H3O+. Okay, all right, so that is if you are using the what do we call that, the alternative method, the simplifying method. Okay, okay, so as you can see, as what we have in the answer scheme also did not provide the, what do we call that, the balance equation. So that is what missing lah. If we are using the alternative method, you tend to miss out the balance equation. Okay, you don't have the, you won't be able to practice unless you make it a habit for you to have the equation first. Okay, because in chemistry you cannot run away from equation, so you need to have the equation. Okay, so how do you write the equation of this weak acid? So this is given to you, right? C9H8O4 H2O. Okay, so you know that this is an acid, it will produce H3O+. Since acid, they donate the proton to H2O, right? It is a proton donor. So one of the hydrogen from these 8 hydrogen will be removed. Okay, will be donated. So later it will become C9H7O4. Okay, and then it will obviously will not be, the charge will not be equal to neutral charge lah. It will not be equal to 0 anymore because it lost its proton. So it will become more negative. So that's why the charge will be -1. As simple as that. Okay, so there you go for your acid dissociation. In case you are asked in exam, okay, to write the equation of the dissociation of the weak acid. So this is how you should be writing it. Okay, so don't forget this, guys. Don't forget this reversible equation because we are dealing with weak acid. All right. This is another checkpoint which is more or less the same as what we had just now. Okay, it's just that this is in terms of base. Okay, this is weak base because we are dealing with morphine the elements, the species in the substance is not there's no element coming from group 1 and group 2. Okay, and then we have nitrogen there, therefore it is a weak base. Okay, so calculate the pH. You have to calculate the pH, and then this is the initial concentration of the morphine. Okay, but before you could calculate for pH, you need to calculate for pOH first, guys, because you are dealing with base, weak base. That means you should bear in mind that you will be producing the OH minus first. Okay, all right, so let's try out the equation first. How would you write the equation? So C17H19NO3 plus water. So since you know this is a weak base, it will produce the OH minus. Okay, that means this morphine will accept the proton from the H2O and it will have extra proton. Okay, all right, so the H can be, you can add in the H in front here, C17H19NO3. Okay, you can place the H added at the front here, at the front of the carbon here, or you can just simply C17, 19 hydrogen will become 20 hydrogen NO3. Okay, don't forget the charge, guys. So it accept proton, right? So that means it will become more positive. That will positive 1 lah, positive 2, positive 3 pula. Initially it is 0. So when it accept 1 proton, it become more positive, which is positive 1. Okay, all right, so you can calculate either using the ICE method or you can also use the alternative method. Okay, so this one you can do it on your own. Then last but not least would be the degree of dissociation. Okay, the degree of dissociation is the extent of dissociation lah. Basically, we want to know the dissociation of the acid. It is also known as alpha, guys. Okay, it is also known as alpha. So it can be calculated as this. Okay, so alpha is equal to H plus or H3O plus divided by HA0. Degree of dissociation can also be represented as change. You imagine your ICE table. Okay, we want to know how much of the acid has been dissociated. So that is like change. Betul tak? ICE yang dekat C tu, change. We know that X, yang negative X, kan? So X is also equal to concentration of H2O plus at the end of the day, right? So that's why the degree of dissociation, okay, how much of the acid has been formed, is also the same as how much of H3O plus produced. It is the same. Okay, and that's why we can calculate the degree of dissociation of H3O plus, concentration of H3O plus over HA0, the initial concentration. So this is for acid, this is for base. Okay, alternatively, okay, you can also calculate by using this Oswald dilution law. Okay, again, it depends on whatever is given to you, what information is given to you. Okay, if you have the Ka and you have the C, you can also calculate the degree of dissociation. But this one is square root of Ka over C. Okay, the one that we have earlier is H3O plus is equal to Ka times C, square root of these two. But this one is lain sikit, slightly different than this one. Okay, don't get confused. Okay, so the degree of dissociation varies with concentration. However, the dissociation constant remains unchanged. Okay, as long as we perform the reaction at the same temperature, that means the dissociation constant means it can be Ka, Kb, or Kw. So this is what it meant by dissociation constant. So these three shall remain constant as long as the temperature is kept constant. Okay. Alright, we can also calculate the percent ionization. It's actually this one, degree of dissociation times 100. Okay, ionized acid concentration at equilibrium over the initial concentration of the acid. This is the same, guys, the same as this degree of dissociation. It's just that you have to times 100. See, the formula is the same as what we have here. Percent ionization, percent dissociation, these two are the same thing. Okay, all right. Concentration of H3O plus divided by HA at initial times 100. That is all. So this is the formula of degree of dissociation. Okay?
Madam,
Yes.
kalau yang guna Oswald dilution law tu sama juga, just darab dengan 100% je untuk personalization.
You have to times you have to get the alpha. Okay? You have to calculate for the alpha and then times 100. This one kan, you have to calculate for the alpha. Okay, you have the alpha and then times 100 because the alpha itself represents this one. Okay, this alpha, if you are using this alpha, you are using this method or this method, you are actually calculating for alpha, betul tak? So in conclusion, we can simply times alpha times with 100. Alpha times 100. Okay, right.
Okay, madam.
Okay, let's look at the example. So a weak acid has a pKa of this. If the solution pH is 3.2, determine the percent ionization of the acid. Okay, the percent ionization of the acid. All right, so percent ionization of the acid. Okay, let's start from the formula itself. Okay, what we want is H3O plus over HA initial concentration. This is percent ionization is equal to times this one times 100, the alpha times 100. Okay, all right, so we need to have these two. Okay, we need to have these two information so that we can calculate for this percent ionization. Right, so the mission is to find H3O plus. Do we have H3O plus? No, it's not given to us directly, but we can extract from this one, right? pH is equal to negative log of H3O plus. Okay, so this we have this value already, negative log of H3O plus. You can simply anti-log this value to get the concentration of H3O plus. Done. You can insert this into here. Next is to find HA. So how can we find HA? So as you can see, we have the pKa. All right, so pKa, we can find out the Ka, right? Negative log of Ka. So we will get the Ka. Okay, we will get the Ka, and then what we want is HA naught, the initial concentration. Okay, all right. So if we can recall that Ka can also be obtained from this formula. Make sure that you know which formula need to be used because we have a lot of formula kan. Ka plus times Kb is equal to Kw. Is that the one that need to be used? No, it's not applicable because we don't have the Kb. Okay, yes, we can find the Kb, but it's a lot of work lah, banyak step dekat situ. Okay, alright, so this one kita dah find out just now, the H3O plus. Ka is also determined just now, okay, from here, and then we can find out the C. So we have these two already. Insert into that, then find out times 100, you can find out the value. Okay, all right. Times 100. Okay, all right, so this checkpoint, you can do it on your own. We will discuss it later during our lecture this evening. Okay, all right, so it's 3:48 now. Okay, all right, so next subtopic will be salt hydrolysis. Okay, just to give you an intro to this subtopic. Okay, so initially we have learned about acid, and then we also have base. Okay, and then we have to determine the pH of the acid and the pH of the base. This is in individual solution. Okay, next up we have salt. We know that salt is the product produced from acid and base. Okay, all right, so normally the pH of the salt, the one that you are familiar, the one that you are familiar with, the salt having pH equal to 7, that neutral pH of salt. Okay, all right, so that is correct. But other than neutral salt, we also have acidic salt, we also have basic salt, and also neutral salt. Okay, so we have the salt itself has its own pH, has its own characteristic, whether it is acidic or it is basic or neutral. Okay, all right, so it depends on the acid and bases that they are combined with. Okay, so this reaction will produce a characteristic of salt, whether it is acidic, basic or neutral. Okay, so jangan ingat salt ni mesti neutral, tak semestinya. Dia ada its own pH, it can be acidic, basic or neutral. Okay, so in later we will look at the pH of the salt, and last but not least, we have to determine the pH of the salt. Okay, all right, so this is the method that we use in order to determine the pH of the salt, whether they're acidic, basic or neutral. It is known as salt hydrolysis. Okay, so that's the idea that I would want to give to you all, so that you get the overview of this subtopic. Okay, and that is all for today, guys. Okay, all right, so we will continue in our replacement lecture at 5 to 6 p.m. Don't forget. Okay, all right, so any question you may forward during our lecture later. Okay, all right, see you guys later, and assalamualaikum. Bye, guys.
Thank you, madam.
Madam. Have a nice day, madam.
Right.
Madam.